Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to discuss how to find the surface area and volume, which is something you have to know how to do in order to be successful on the Armed Services Vocational Aptitude Battery. As always, I strongly encourage you to make an effort to work out all the problems from today's video on your own scratch paper. That is, I recommend that you pause the video after I read a question, attempt to work it out on your own paper, and then resume playing the video to see if you and I came up with the same answer in the same way. On the ASVAB, you're not allowed to use a calculator or a formula sheet. So at some point, you're going to have to devote all the formulas we discussed today to memory. So in light of that, let's go ahead and get started with today's video. Again, as I mentioned, we're talking about surface area and volume today. Just a quick reminder, volume corresponds with cubes and surface area and area corresponds with squares. Okay, and you can see that right here for cubes. Volume cubed, surface area squared. Okay. If I were taking the ASVAB and I wanted to do well on it, I might only spend my time learning 3 of these formulas. That is, I would only learn how to find the surface area and volume of cubes, rectangular prisms, and cylinders. That said, if I wanted to score somewhere between 90 and 99, I would make an effort to learn how to find the volume and surface area for these other shapes as well. So with that said, I want to start this video by looking at the formulas very quickly. In all honesty, just looking at the formulas isn't going to do much for you. So as soon as I get done talking about these formulas, I'm going to make an effort to do practice problems for every single one of these shapes. And in doing so, I think that will help increase your understanding of how these formulas work. Let me say this. There's really not that much to memorize here because all these formulas, for the most part, are derived from the area of squares, rectangles, and circles. So if you understand how to find the area of a square, rectangle, and circle, you'll see that most of these formulas are pretty easy to commit to memory. So let's run through the formulas real quick, and then we'll do some practice problems. And then at the very end of this video, we'll do some ASVAB practice questions. So to find the volume of a cube, you take one of its sides and cube it. To find its surface area, you take one of its sides, square it, and multiply it by 6. In case it's not obvious, surface area refers to finding the area of all the faces of a shape. And in a cube, there are 6 faces, all of which are the same. So basically, you're finding the area of one of these faces, which is s squared, and then you're multiplying that by 6, since there are 6 faces in a cube. Volume is in regard to how much a certain object can hold. So imagine pouring water into this cube. If you poured water and filled up this cube with water from bottom to top, that would be its volume. So again, I just want to mention that that is the key difference between volume and surface area. So let's talk about rectangular prisms. As we can see, the volume for that is length times width times height. And the formula to find its surface area is 2 length times width plus 2 width times height plus 2 width times length. Okay. To find the volume of a cylinder, it's pi r squared times height. And to find its surface area, it's 2 pi r times height plus 2 pi r squared. Again, I'm just going to run through these very quickly. And then as we do the practice problems, I'm going to point out how these are related to their area formula, their formulas to find the area of circles, squares, and rectangles. For cone, you just need to know how to find volume, and that's 1/3 pi r squared times height. For square or rectangular pyramids, the volume is 1/3 length times width times height. And finally, for isosceles, triangular prisms, volume is 1/2 base times height times length. And surface area is base times height plus 2 length times side plus length times base. Okay, so if you'd like to, I would write down these formulas. That way, when we get to the practice problems, which we're going to get to in about a minute here, you can refer back to them. Since I'm only going to make one video on volume and surface area, you may want to go through this video once using the formulas, and then after you get a good handle on those formulas, wait a day or two and then come back and go through the video again and see if you can do the problems without the formula sheet that you have there. Okay, so, but that said, hopefully by the time I get done with this video, you'll have a deeper understanding of how these formulas are related to area of squares, rectangles, and circles, and you really won't need that formula sheet for that next time you go through this video. With that said, let's start by finding the surface area and volume of a cube. And as you're going to see, I'm not going to refer back to that formula sheet because I know how these are related to area. So let's start with volume. Sometimes I think volume's easier to find. As we saw above, volume of a cube is going to be S cubed, where S refers to one side of the cube. In this case, we can see that one side is 6, so this is going to be 6 cubed. And so we have 6 cubed, which is the same as 6 times 6 times 6. That's good luck Chinese number. 6 times 6 is 36 times 6. Let's work that off to the side here. This is 36 times 6. 6 times 6 is 36, so you have to carry a 3. 6 times 3 is 18, 19, 20, 21. So we can see the volume of this cube is 216 millimeters cubed. Okay? To find the surface area of this cube, again, surface area is asking you to find the area of all the faces of an object. In a cube, all the faces are the same and there's 6 of them. So let's talk about how to derive this formula from our knowledge of area of squares. Again, we have, as we can see, 6 by 6 face for all of the faces of this cube. So to find its surface area, we're going to take the area of one of its faces, which is going to be S squared, and we're going to multiply that by 6. Okay, and just like that, I derived the formula. So let's go ahead and plug things in. 6, S squared, as we can see, is 6, so we'll plug that in. 6 squared, as we know, is 36, so this is 6 times 36. As you can see, that's basically what we have here, so without doing any more work, we know this is 216 millimeters squared. Okay? So that's cubes. Not too much going on with cubes. All right, so let's move on to a rectangular prism, or a box as it's called. Let's start with volume. Volume is very easy to figure out. And again, for volume, try to imagine filling this box up with water. Volume in this case is going to be length times width times height. And as we can see, this is our length, this is our width, and this is our height. So let's plug those things in accordingly, and let me label that for you. Length, width, height. So this is going to be 11 times 3 times 4. 3 times 4 is going to be 12, so this is 11 times 12. Let's work that off to the side in case we need to. Again, this is 12 times 11. 1 times 2 is 2. 1 times 1 is 1. Drop down a 0 placeholder before you start working with that number. 1 times 2 is 2. 1 times 1 is 1. Let's add. 2 plus 0 is 2. 2 plus 1 is 3. 1 plus nothing is 1. So we can see the volume of this cube is 132 millimeters cubed. Okay. And let me get rid of this work so I can have room for the surface area. And At this point, we might be saying to ourselves, I don't know what the formula is to find the surface area of a cube. Well, again, surface area is in regard to finding the area of all the faces of an object and adding them up. And in a cube, you have 6 faces, and all the faces happen to mirror each other. So let me try to draw this for you. This is this front face right here. And this front face mirrors its back face. So we can see that we're going to have to find the area of the front and back face, which is going to be 2 times the area of one of them. And as we can see, this length of this front face is 11, and the height of this front face is 4. So to find the area of one of these rectangular faces, it's going to be 4 times 11. More specifically, it's 2 times length times height. Okay? All right, so that's the front faces. As you can see on this rectangular prism, we have side faces, which kind of look like this. They mirror each other. And again, we can see that it's a 3 by 4, where 3 refers to the width and 4 refers to the height. Again, there's 2 of them, so we know it's going to be 2, and then that's going to be width times height. Let's go ahead and move over a little bit. And finally, we have this bottom face and this top face. Let me try to draw those for you. That's the bottom one. That's the top one. As you can see, they mirror each other, where its length is 11 and its width is 3. So we're going to need 2 of those as well. Again, that's going to be length times width. Okay, so this is the formula for surface area, which is, again, adding up all of the areas of all the faces in this rectangular prism. Okay, so that's it. Let's plug things in now. And you may notice that this formula is not exactly as it's written above. Again, I derived this formula using my knowledge of surface area as well as area of rectangles. So it is the same thing, it's just a little bit out of order. So in this case, let's just plug things in accordingly. We have length times height, so that's 4 times 11 plus 2. Width times height, that's going to be 4 times 3 plus, finally, length times width, which is 11 times 3. All right, let's go ahead and work this out. And since I don't know the backgrounds of people watching this video, I'm not going to skip any steps as I do this. I'm actually going to drop down a line to give myself more space. This is going to be 2 times 4 times 11 is 44 plus 2. 4 times 3 is 12 plus 2 times 11 times 3, which is 33. All right, 2 times 44 is going to be 88 plus 2 times 12 is 24 plus 2 times 33, which is going to be 66. Let's go ahead and work this out now. Unless you can do this in your head, I recommend you do it off to the side like this. 88, 66, 24. Okay. 6 plus 4 is 10, plus 8 is 18. So you're going to carry a 1. 8 plus 2 is 10, plus 6 is 16, plus 1 is 17. So we can see that this surface area is 178 millimeters squared. Okay. So again, that's how you find surface area of these rectangular prisms or boxes. All right, let's move on to this cylinder. All right, for number 5, you can see that we have to find the volume and surface area of this cylinder. As it happens, it's usually easier to find volume. So let's start by doing that in this case. Again, let's think about what we're doing in terms of finding volume. We're trying to find how much liquid or how much space is inside this object. So to do that, what you do is you find the area of one of these circular faces, and then you just multiply it by its height. So we all know how to find the area of a circle. That's pi r squared. And in this case, all we have to do is multiply by its height to get its volume. In this case, as you can see, we were given the diameter and we need the radius for the volume formula. Diameter is always twice as long as the radius. So if the diameter is 4, the radius is going to be 2. So let's just go ahead and plug that in. This is going to be pi. Let's plug in 2 for r times height. Let's work this out. This is going to be, oh, and I forgot to plug in height there. Let's go back and do that real quick. Okay, we know its height is 6. So this is pi, and I'm not going to skip any steps as I do this because I don't know who's watching this video. 2 squared is the same as 4, and this, of course, is times 6. 4 times 6 is 24, so this is 24 pi. And on the ASVAB, you couldn't leave this as your answer. Again, you're going to have to make use of the fact that pi is approximately 3.14 and actually work this out. So let's go ahead and do that down here. Again, we're going to do 3.14 times 24. In this case, we should recognize that we're multiplying a decimal by a whole number. So in light of that, we're going to have to shift this decimal 2 times to the right to make this 314 times 24. And at the end of doing this arithmetic, we'll shift that decimal back into the left. So 4 times 4 is 16, carry your 1. 4 times 1 is 4, plus 1 is 5. 4 times 3 is 12. Add a 0 placeholder since we're starting this number. 2 times 4 is 8. 2 times 1 is 2. And then 2 times 3 is 6. Let's add 6 plus 0 is 6. 5 plus 8 is 13. Carry your 1. 2 plus 2 is 4, plus 1 is 5. And then 6 plus 1 is 7. Shift in your 2 decimals, 1, 2. So we can see the volume in this case is approximately 75.36 yards cubed. And again, I say approximately because we use this approximation for pi. Right, surface area is a little bit more challenging, but that said, let's discuss what we have going on here. Again, surface area is the area of all the faces in this shape. So we can see that we're going to have to find the area of this circular face as well as this circular face. Okay, so that's going to be, we know how to find the area of a circle. That's pi r squared. But in this case, there's actually 2 of them, so we're going to have to multiply that by 2. And to find the surface area of this shape between the squares, what we're going to do is find the circumference of one of these circles and then multiply that by the height of this cylinder. So that's going to be, how do we find circumference? That's going to be 2 pi r times height. Okay? And if we take a look, we can see just like that, I derive the formula for surface area. Again, just using my knowledge of area as well as circumference and what surface area is asking, I was able to derive that with no other knowledge. So in light of that, let's plug things in and solve accordingly. And let's get this nonsense out of the way right there. All right, so now it's just a matter of plugging things in accordingly. Surface area equals 2 pi r squared. In this case is 2 squared, so this is going to be 2 squared plus 2 pi. R is 2, so that's 2 times height, which is 6. Let's work this out, and I'm not going to skip any steps as I do this. This is 2 pi. 2 squared is 4 plus 2 pi. 2 times 6 is going to be 12. All right, let's simplify this by multiplying 2 and 4, which is going to be 8 pi plus 2 times 12, which is going to be 24 pi. 8 pi and 24 pi are like terms, so we can add them together. 8 and 24 is going to be 32 pi. And as we did over here, we can't leave pi in our answer more often than not. So we're going to have to do 3.14 times 32. Again, we should recognize that we're doing multiplication with a decimal and a whole number, which is going to prompt us to shift our decimal such that it makes this decimal a whole number as well. And in this case, to make 3.14 a whole number, we're going to have to shift the decimal 2 times to the right, which is going to make this 314 times 32, albeit with 2 decimals to shift back into the left at the end. So this becomes 4 times 2, which is 8, 2 times 1, which is 2, 3 times 2, which is 6. Now we're starting this number, so we have to add a 0 placeholder before we begin. 3 times 4 is 12, carrier 1. 3 times 1 is 3, plus 1 is 4. 3 times 3 is 9. Let's add. 0 plus 8 is 8. 2 plus 2 is 4. 6 plus 4 is 10. Carrier 1. 9 plus 1 is 10. Shift your 2 decimals in. 1, 2. So we can see the surface area of this cylinder is approximately 100.48 yards squared. And I say approximately, again, we approximated pi to be 3.14. Okay, so that was that one. For number 7, you can see we have to find the surface area and volume of this isosceles triangular prism. As you can see, this has 2 triangular faces sandwiched by 3 rectangles, which is important when we're going to find its surface area, so just keep that in mind. In this case, I know this 4 is its base, this 11 is its length, and this 3 is its height. So let's go ahead and start by working on volume. Again, volume is usually always easier to figure out than surface area for some reason. To find volume, what you're going to do is find the area of one of these faces and then multiply it by the length of the object. So in this case, to find the area of this triangle, it's going to be 1/2 base times height. Then, as I mentioned, we multiply that by the length or height of the object. In this case, this is the length. So this is 1/2 base times height times length. That is, we have the area of a triangle times the length of the entire object. So let's go ahead and solve accordingly by plugging things in. This is 1/2. Base is 4. Height is 3. And the length is 11. Okay, so I'm going to make this math a lot easier by taking care of this 1/2 real quick. I'm going to do 1/2 times 4, which I know is 2. So that leaves us with 2 times 3 times 11. In other words, that's going to be 6 times 11, because that's 2 times 3 is 6, times 11, which is going to be 66 centimeters cubed. Again, cubed since it's volume. All right, so to find the surface area, we have to find the area of all the faces in this object. And as we can see, there's 2 triangles, 1, 2, which mirror each other. Then there's a base rectangle and 2 side rectangles, which mirror each other. So there's 1, 2, 3, 4, 5 faces we have to find the area of and then add them together. Finding the area of these triangles is straightforward. Again, area of a triangle is 1/2 base times height. But that said, there's 2 of them. So it's going to be 2 times 1/2 times base times height. So the 2 and 1/2 are going to cross out. So that's just going to be base times height. Okay, so we've taken care of the triangular faces. So that's done. Again, it's going to be plus. And again, there's only one base for this shape. And it looks like this. There's only one of those. It doesn't mirror anything. And it's 4 by 11, and as we can see, it's base and length. So that's going to be plus base times length. Again, that will give you the area of its base. And then, as I mentioned, we have these two side faces which face each other, and they're kind of like this. Let me see if I can draw it real quick. This one's going to be pretty hard to draw. Looks like that. And for this one, they need to give us the side. So it's going to be, the length of this side is 5 centimeters. I forgot to add that. Okay. So as we can see, this is like this panel right here. And to find its area, we're going to take this thing, which is called the side, times its length, which is right here. So this one's going to be plus 2, since there's two of these mirroring each other, side times length. Okay, so that is the formula for surface area, which I derived by looking at this shape. So let's go ahead and plug things in and solve. Base times height is going to be 3 times 4, plus base times length, which is 4 times 11, plus 2 side times length, that's going to be 5 times 11. All right, let's work this out step by step. 3 times 4 is 12. 4 times 11 is 44. 5 times 11 is 55. Of course, that's times 2. Let's work this out real quick. 55 times 2. 5 times 2 is 10. Carry your 1. 5 times 2 is 10 plus 11 is 110. So this is surface area equals 12 plus 44 plus 110. So now let's just add all of those together. That's going to be, and I'm going to do it off to the side here vertically. It's going to be 110, 44, and 12. 0 plus 4 plus 2 is 6. 1 plus 4 is 5 plus 1 is 6. And then 1 plus nothing is 1. So this is 166 centimeters squared. Okay, so that was that one. All right, for this one, we can see that we're dealing with a rectangular or square pyramid. And to find its volume, which is all we need to know how to do for the ASVAB, the formula is 1/3 times the area of its base. The area of this base, as you can see, is length times width. This is 1/3 length times width. And then that's going to be times the height as well. Okay, so again, this is 1/3 times the area of the base times the height of the object. And that's it for finding the area of a square or rectangular pyramid. As we can see, we can call this the length, and this one's going to be the width. So let's plug those in accordingly, and we can see our height is right here at 11. So this is going to be 1/3 3 times 3 times 11. Let's get rid of this fraction. 1/3 times 3 is just 1. So in other words, those just cancel out, leaving us with 3 times 11, which is, my pen acted up there, 33 inches cubed. Okay, so that was that one. For number 9, you can see that we have to find the volume of this cone. It's fairly straightforward. That is, we're going to find the area of this base of the cone, which is a circle. We're going to multiply that by its height, and then we're going to multiply that by 1/3. So to illustrate that, that looks like this. Volume equals 1/3 area of the circle, which is pi r squared times height. So again, that's the volume to find. That's the formula to find the volume of this cone. Let's go ahead and plug things in accordingly. This is 1/3 times pi. The radius, as we can see, is 4. So this is 4 squared times height, which is going to be 12. And my pen's acting up a little bit. Let's keep working this out. This is 1/3 pi. 4 squared is 16, so this is times 16 times 12. And I want to get rid of this fraction before I proceed. So I'm going to take 1/3 and multiply it by 12. That's the same as 12 divided by 3, which is going to be 4. So this is pi times 16 times 4. All right, so let's work that off to the side. That's going to be 16 times 4. 4 times 6 is 24. Drop down your 4, carry your 2. 1 times 4 is 4, plus 2 is 6. So we can see that this is going to be 64 pi. Again, on the ASVAB, you'll likely have to work this out by approximating pi as 3.14. So let's go ahead and do that. We're going to do 3.14 times 64. Again, we're multiplying a decimal by a whole number. In order to do this, we're going to have to shift this decimal 2 times to the right to make 3.14 314. So in reality, we're doing 314 times 64, albeit with 2 decimals to shift back in at the end. 4 times 4 is 16, carry your 1. 4 times 1 is 4, plus 1 is 5. 3 times 4 is 12. Add a 0 placeholder since we're starting this number. 4 times 6 is 24, carry your 2. 6 times 1 is 6, plus 2 is 8. 6 times 3, of course, is 18. Let's add. 6 plus 0 is 6. 5 plus 4 is 9. 2 plus 8 is 10, carry your 1. 8 plus 1 is 9, plus 1 is 10. Carry a 1. 1 plus 1 is 2. Add your 2 decimals back in. So we can see the volume in this case is going to be approximately 200.96. And then this one is given in yards, so yards cubed. Okay, so that was that one. All right, for this one, you can see that we have to find the volume of this sphere. And as I mentioned, volume for spheres is not that easy to derive just by looking at a sphere. So in light of that, it's a good idea to memorize this one. It's 4/3 pi r cubed. As we can see, 2 is our radius. So let's go ahead and plug that in. That's 4/3 pi times 2 cubed. So this is going to be 4/3 pi. 2 cubed is the same as 2 times 2 times 2, which is just 8. So as you can see here, we have 4/3 times pi times 8. If we disregard this pi for a moment, we can see that we have 4/3 times 8. That is, we have a fraction multiplied by a whole number. Let's reduce this before we continue to make the math a little bit easier. So to multiply a fraction by a whole number, you make the whole number a fraction by placing it over 1. And then you just multiply straight across. So this becomes 4 times 8, which is 32, over 3 times 1, which is 3. So we know the volume in this case is going to be 32 over 3 times pi. And I'm going to leave it like that. In this video, I've worked out quite a few decimals. On the ASVAB, if you're given a sphere and asked to find its volume, chances are they're not going to make you approximate pi. They'll just let this be an answer choice. So that was that one. All right, now that we've done some very basic practice problems, let's take a look at a few word problems which may mirror what you'll see on the ASVAB. This one says Sandy is filling her swimming pool. The pool is in the shape of a rectangular prism and is 30 feet long, 15 feet wide, and 8 feet deep. Sandy wants to leave the top 2 feet of the pool unfilled to prevent spilling. How much water will it take to fill the pool? So let's start by making a diagram. Again, we know we're dealing with a rectangular prism. So it's going to look something like this, and I'm going to give you the side view of it. And that's bad, so let me fix that real quick. Okay, so that's the side view. Imagine this is the ground right here. And she wants to find out how much water it's going to take to fill this pool. We know it's 30 feet long, so this is 30 feet. It's 15 feet wide, so we know this is 15 here. But that said, she wants, the pool itself is 8 feet deep, but she only wants to fill it with 6 feet of water to prevent uh, spilling. So technically, this entire height is 8. That said, she's only going to fill it 6 feet. Okay? So again, the water in the pool is only going to go up to 6 feet. In light of that, we have to realize that we're going to need the formula to find the volume of this rectangular prism. And that's simply length times width times height. We know our length is going to be 30. You know the width is 15. And instead of using 8 for the height, which is in fact the height of this rectangular prism, we're only going to use 6 since that's how high she wants the water to go up. So this is going to be 30 times 15 times 6. All right, so now we're just going to work this out and we'll have our answer. There's no real easy way to do this one. As you can see, we're doing multiplication with some pretty big numbers here. So I'm going to start by doing, let's do 30 by 15 to start. 0 times 5 is 0. 3 times 5 is 15. Add a 0 placeholder since you're starting this number. 1 times 0 is 0. 1 times 3 is 3. Let's add. 0 plus 0 is 0. 5 plus 0 is 5. 3 plus 1 is 4. So this is 450 times 6. Let's work that off to the side. 0 times 6 is 0. 5 times 6 is 30. Carry your 3. 4 times 6 is 24. 25, 26, 27. So to answer the question, to fill up this pool to 6 feet deep, Sandy would have to add 2,700 cubic feet of water. Okay? All right, this final problem says the excavation for a house and the trucks to carry away the material have the dimensions shown. We can see those in this little diagram over here. About how many level truck loads are necessary to remove the dirt. Okay, so we're excavating underneath a house. As you can see, that shape is a rectangular prism. And similarly, the bed of this truck is also a rectangular prism. To find out how many loads it's going to take to complete the excavation, we're going to find the volume of the pit. So that's going to be volume P. And since it's a rectangular prism, we're going to know its length times width times height. And we're going to take that and divide it by the volume that each truckload takes away. So I'm going to call that volume of TL for truckload. Again, that's going to be length times width times height. And by finding the volume of the pit divided by the volume of the truckload, that will tell me how many loads are necessary to remove all the dirt. So let's go ahead and get started. Let's plug things into both formulas first. Again, this is 11 times 14.5 times 4. And I just grabbed those from this diagram here. That's all going to be divided by volume of TL, which is going to be up here. 5 times 2 times 3. Okay, I'm going to start by finding the volume of a truckload, since that's easier. Volume of a truckload is going to be 5 times 2, which is 10 times 3, which is 30 meters cubed. Now let's work this out. Again, the volume of the pit, that's going to be 11 times 4, which is 44. 44 times 14.5. So this is going to be 44 times 14.5. And again, in case that's not obvious, let me add another line here. I did 11 times 4, which is 44, which leaves me with 44 times 14.5. So 44 times 14.5, as we can see, is a whole number times a decimal. In order to do this, we're going to have to shift this decimal to make it a whole number as well. More specifically, we're going to shift it one time to the right to make 14.5 145. And at the end of doing this arithmetic, we'll shift that decimal back in. So this is going to be 145 times 44, albeit with one decimal to shift back into the left at the end. 5 times 4 is 20, so we'll carry our 2. 4 times 4 is 16, 17, 18, carry our 1. 4 times 1 is 4, plus 1 is 5. Add a 0 placeholder since we're starting this number. 4 times 5 is 20, carry a 2. 4 times 4 is 16, plus 2 is 18, add a 1. 4 times 1 is 4, plus 1 is 5. So let's add 0 plus 0 is 0. 0 plus 8 is 8. 5 plus 8 is 13. Carry your 1. 5 plus 1 is 6. Bring in your 1 decimal so we can see the volume of this pit is 638 meters cubed. Now we just got to do this division to figure this one out. And as you can see, that's going to be 638 divided by 30. So let's do this long division and we'll be done. And let me get this work from a previous video out of the way. All right, so now we're asking ourselves, how many times does 30 go into 6? It doesn't. 6 is too small. How many times does 30 go into 63? That's going to be 2 times. 2 times 30 is 60, so we're going to subtract. 63 minus 60 is 3. We're going to drop down this 8. Now the question is, how many times does 30 go into 38 without going over? It's going to be 1 time. 30 times 1 is 30. We're going to subtract. 38 minus 30 is 8. Now the question is, how many times does 30 go into 8 without going over? It doesn't, so we have to add a 0. So now the question, and when we add that 0, it's going to prompt us to bring a decimal up here. Now the question is, how many times does 30 go into 80 without going over? That's going to be 2 times. 30 times 2 is 60. And at this point, I'm going to stop. And to answer this question, it's going to take about 21.2 truckloads. But since you really can't take just half or 0.2 of a truckload, it's going to be 22 truck loads. Okay, so that's the answer to that one. That's all I have for you in this video. I hope you found it helpful. In all honesty, this is one of the hardest videos I've uploaded recently, given that we covered about over 10 different formulas in this video. Hopefully you found it helpful. Again, as I mentioned, if you just want to learn the bare minimum for the ASVAB, just focus on learning surface area and volume for cubes, rectangular prisms, and cylinders. Chances are you're not going to see any of these other figures on the ASVAB. But if you like the content I'm creating, go ahead and click subscribe. In addition, you're more than welcome to leave some feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.